All right, this is a challenge in a real-world connection problem on absolute value functions. I encourage you to pause this video and try these on your own and then check back in and see how you did. All right, let's do this one on the left first. It looks like an interesting function, y equals the absolute value of x minus x. So we have an absolute value piece and then just a regular linear piece, the minus x, kind of combined together. So I think the easiest way to do this, it's probably hard to think about what this might look like just using your brain. Let's make a table, plug in some points. So we'll first take the absolute value of x, and then we'll subtract away what x is. So the absolute value of negative 3 is 3, and then we'll subtract away a negative 3 to get a 6. The absolute value of negative 2 is 2, and subtract away a negative 2 is adding positive 2, gets us a 4. This is going to turn into a 2, and that's a 0. Okay. Here in this case, the absolute value of when x is 1, the absolute value is 1, minus 1 is 0. Then can you predict what's going to happen? They just cancel out, right? We just get a whole bunch of zeros. So we have sort of an interesting pattern going on here. Let's graph it in purple here. So when x is negative 3, we're up 6. 1, 2, 3, 4, 5, 6. Negative 2, we're up 4. 2, 3, 4. Negative 1, we're up 2. And then 0. And then we just have a whole bunch of zeros forever. Okay, so we have that piece first, and then that piece continuing. All right, so that's an interesting looking graph right there. It's definitely a piecewise function, but the pieces aren't symmetric. Okay, you're driving at 40 miles an hour towards a stationary tornado. Don't actually do this, please. You pass through the tornado, miraculously survive, and continue driving. Create an equation and graph the model of your distance from the tornado. Okay, so we are going to graph here. We are going to graph time versus distance. Okay, and we don't really have enough information to really ensure that we all get the same answer. So there are going to be some different answers in here for sure. Let's keep things simple. Let's keep things in terms of hours. And let's say this is such a giant tornado that from a couple or more hours away, you can see it and you can drive towards it. So let's say we started out perhaps 3 hours away. Okay, let's just go up in hours. 1, 2, 3, 4, 5. Okay. And let's say we started, I'm going to keep the numbers kind of nice and friendly, 120 miles away from the tornado. Okay. So we can go up by 30s here. 30, let's go up by 20s. 20, 40, 60, 80, 100, 120. So at the beginning, we were 120 miles away from the tornado, driving straight towards it. Okay? An hour later, we were 40 miles closer. An hour after that, we were another 40 miles closer. And at exactly 3 hours, we were exactly in the middle of the tornado. I hope we survived, and we were able to keep on driving in the same direction. Okay, so after another hour, then we were 40 miles away from the tornado, and then our distance increased. So I hope you can see that we have a absolute value function. We can even come up with an equation for this. Well, we're supposed to come up with an equation for this of this graph. So we have a couple things to keep in mind. We have the vertex is at 3, 0. Okay, and let's find the slope of this right-hand arm. That is 40 over 1. Makes sense, right? Our speed was 40. Okay, so it looks like the distance that we are from the tornado can be modeled by y equals 40 times x minus 3. Okay, so for any particular number of hours that we've been driving, we could determine what our distance from the tornado is. And I made a mistake. It shouldn't be a parentheses. We're dealing with absolute value, right? So those should be absolute values right there. Nice. That's a good place to stop.